All right, well, hopefully you found that interesting, and you can see the tie-in to chapter 2 with the falsifiability issue, as well as the issue that we're facing today, which is the pseudoscience issue. Let's talk finally, let's wrap up this chapter on a positive note and talk about actual research, controlled studies. These are going to be I'm going to focus on experiments in this section, not just any kind of study, but controlled studies where the researcher actually has control over the variables. So what we're talking about here is an experiment. And I'm just going to give you a little baby introduction to experiments. We're going to talk about experiments in other chapters as well. But this is sort of hopefully going to serve as a reminder for things that you might have learned in Intro to Psych or other places. So in an experiment, you have an independent variable. And the key thing in a controlled study is that the experimenter has control over that variable. It's going to be manipulated by the researcher. When we say that it's being manipulated, what we mean is the researcher is going to randomly assign some of the participants to one condition and some of the participants to another condition, at least 2 conditions. There's going to be at least 2 conditions in any experiment. So one condition you might call the experimental condition, and the other one you might call the control group. You might call them those. We're going to find as we go on that psychology doesn't always have a clear-cut control group, but let's just keep this simple right now and say we're going to randomly assign the participants to an experimental group or to a control group. Okay. Then we have in every experiment a dependent variable, and that is the output that is being produced by the participant. Hopefully that output is in response to being in the experimental condition or in the controlled condition. So this is the thing that the researcher is actually going to measure. So the researcher controls the independent variable and measures the dependent variable. Ideally, the dependent variable, whatever the participant produces, should depend on the condition they were in the independent variable. The independent variable is called independent because you are either in one group or you are in the other. Those groups are independent of each other. You can't simultaneously be in both. There are some uncontrolled or less controlled types of experiments that we'll talk about later, where you can have the same people in the same groups, but we're not talking about that right now. In case you're more advanced and you know about other kinds of designs, I just want to clarify that is not what we call a controlled study. This is what we call a controlled study, where there is an independent variable and I, as a researcher, randomly assign you to this condition or that condition, and it is an or, it's not an either, it's not an and. You are either experimental or you are control, you are not both. All right, and then hopefully, being in the experimental group will cause you to produce a different score on the dependent variable than being in the control group causes you to produce. Because we want to see whether the experimental thing that we're trying out actually has an effect, right? So this is the basic format of an experiment. This is what we mean by a controlled study. Now, in the control condition, you might go one step further, not just don't give them the experimental treatment, but you might actually give them something that they think is a treatment, and that's what we call a placebo. I mentioned this earlier in an earlier part of the same chapter. Placebos are when you think you're getting a treatment, but you really are not. You're getting something inert. So when we use placebo controls, they are always at least single-blind studies where the participant doesn't know whether they are getting the real treatment or they're getting a placebo. You don't tell the participant, okay, so we're giving you a sugar pill, but pretend like it's actually an antidepressant. Like, we don't do that. The participant doesn't know what condition they're in. So that, if the participant doesn't know what condition they're in, that's called a single blind study, where the participant is blind to their own condition. I gave you an example of an old dating show from, like, I don't know, 2001 or something. It was hosted by Monica Lewinsky, and it was called Mr. Personality. And the premise, it's very much like Dating in the Dark is today. But the men, when they weren't in the dark, had to walk around with these masks on, like you see in the picture. And there was one woman, they could all see her. So the only person who was blind to the potential mate's appearance was the woman. The men were all able to see her. So it's a single blind study, right? She's blind. they're not. Okay. Double-blind studies are when neither the participant nor the researcher who comes in contact with the participant know what condition the participant's in. So here we have a bunch of people with blindfolds on, and some are under the sign that says Group A, and some are under the sign that says Group B. And somebody says, "Who's up for a game of blind man's bluff after dinner?" In a double-blind study, somebody needs to know what condition they're in. The overarching, responsible researcher needs to know whether Group A or Group B is getting the active ingredient. But the person who's coming in contact with them, that researcher who's sitting in the room with them, is blind to their condition so that he doesn't treat them differently or see changes in behavior that he wants to see, that he expects to see based on knowing that they're in one condition or the other. And so both the researcher and the participant are blind, and that's why it's called double blind. Just for shorthand, just to clarify, always the participant is blind. So every study that you can ever think of is at least single blind. Sometimes we have double blind studies. There are a lot of reasons for having double blind studies. Sometimes the researcher really wants a particular outcome, and a way to prevent the researcher from making it happen because they want it is to make that researcher blind to what's going on. And that way they can't act differently because they don't know. They can't treat the participants differently or elicit certain kinds of answers or whatever. They can't because they don't know. And so you protect yourself from your own self sometimes by having double blind designs. Sometimes we have double blinds because we literally have active ingredients that we're trying or something like that, and we don't want to encourage any kind of placebo effects. So, and we're going to talk about the placebos more when we get to another chapter, so we'll come back to that. So let's talk about the McCabe and Castell study, where you had people either just reading the text or seeing the bar graph or seeing the brain image. So what would you call a placebo condition in this scenario? The text, the bar graph, or the brain image? Give you a second to think about it, and then I'll tell you the answer. So if you don't want to hear the answer yet, stop me. Okay, I would say that the placebo condition would be the bar graph, because we want to give them something visual, but not a brain scan. And so a bar graph would serve that purpose. The text is probably just what we would call control condition. It's not getting a placebo, it's just getting a control. So you've got a control condition called text. The information's there. We have a placebo control condition where we give something visual in addition to the text that's not a brain scan. And then we have the experimental condition, which is the brain scan. Now, would you say, not knowing anything else about this study, would you guess that this was a single blind study or a double blind study? Think about that for a second. Pause me if you need. Okay, going to reveal the answer here. All right, so the correct answer is single, because the participants don't know probably even that there are other conditions, right? The participants are just given their articles to read with whatever accompaniment, the nothing, the bar graph, or the brain image, and so they don't know anything about the other conditions. The researcher probably does know what condition they're in, and probably because it doesn't matter. Like, it's unlikely that the researcher could cause the person to value the brain scan more than the bar graph or whatever. So probably they didn't bother with a double blind in this scenario. So that was probably a harder question, because maybe the reasoning it out might have made it a little bit more complicated. So the purpose of a placebo or a control group, now follow along with me. A lot of people I've noticed sort of look at this slide in a static way and misunderstand what it's depicting here. So the purpose of a placebo or a control group. Okay, let's say that the experimental group scores differently from the control group, whether it's placebo or just regular control, it doesn't matter. Let's just say the experimental group does in fact score differently from that group. We could infer that the treatment was effective and that the treatment caused the experimental group to score differently. We could eliminate the alternative explanation that it was due to placebo effects because we're seeing the experimental group scoring differently from the group that got a placebo. The placebo wasn't powerful enough to compete with the experimental treatment. And so when we see the treatment, when we see the experimental group being different, that means that the placebo wasn't powerful enough to be equal to that treatment. The treatment was meaningfully different, better, more, whatever you want to say. So when we see that difference in scores, we can say our treatment worked. Having a controlled study with random assignment allows us to say that. Be confident that we know that the experimental treatment caused the outcome. And we can eliminate the alternative hypothesis that placebo could have worked as well because we included a placebo condition. All right, what if the experimental group and the control group score the same? Okay, so see these different outcomes, right? So now in the green, the second example, I'm saying we got no difference between groups. What can we infer from that? Well, it's possible that the treatment doesn't work. It's possible that that's the failure. But it's also possible that the treatment worked, but the placebo works just as well, right? It could be that the treatment is effective, the placebo is effective. Expectations are good enough to cause a change in behavior. Now, if we got that outcome, we'd have to test that hypothesis by maybe continuing the study for a longer period of time to see if the placebo loses its effectiveness, right? That happens a lot of the times. You get an initial effect where the placebo seems to be working, but then over time it goes away. So maybe that's what we would discover if we continued the study. And then we would be able to eliminate the hypothesis that the placebo is just as good as the experimental treatment. Maybe it's good initially, but then it loses its effectiveness, and then maybe the real treatment continues to work. Right? So that's what you do in science. You keep testing these hypotheses and you try to eliminate alternative explanations while maintaining the ones that seem to be the best descriptions of the outcomes. So that's why we do controlled studies. Okay, here's a little review of what we've covered today, and I wanted to show you a book that you might find interesting to read. It's actually really well written and has a lot of fun stories in it, called Pseudoscience, An Amusing History of Crackpot Ideas and Why We Love Them by Lydia Kang and Nate Peterson. So if you're at all interested in the subject of pseudoscience and maybe you want to have something to read, on the next break, maybe you want to check this one out. So, all right, it's been fun talking about pseudoscience. I will see you in the next chapter.